Good morning students, welcome to next lecture of switching theory and logic design. In this class we are starting unit 4, right? In our yesterday the 4th unit syllabus is sequential circuits part 1. Our 5th unit is sequential circuits part 2. In this part 1 we are going to see the concepts of the first one, classification of sequential circuits, that is what is meant by a sequential circuit, and next we will see what are the different types of sequential circuits, like synchronous and asynchronous circuits are available. We will see their definitions and operation of NAND and NOR latches and flip-flops. So the flip-flops and latches basic constructions we have started with NAND logics or NOR logics. Those we will see there, and truth tables and excitation tables of RS flip-flop, JK flip-flop and T flip-flop and D flip-flop with clear and reset terminals. So here we have totally 4 different types of flip-flops or latches. They are SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. Those operations we will see with the help of 2 terminals like reset and clear terminals. Next, we will see the conversion of flip-flops from one flip-flop to another flip-flop. So conversion from one flip-flop to another flip-flop, we will see the concept. Next, design of registers and design of counters. In the design of registers, we will see buffer registers, control buffer registers, shift registers, bidirectional shift registers and universal shift registers. So with this we will see the counters, design of counters, ripple counters, asynchronous counters, synchronous counters, Johnson counters and ring counters we will see here. Next, coming to that, this Johnson and ring counters are the applications of shift registers. We can see in the 2 directions, from the counter direction and registers directions we will see these 2, and study of the following relevant IC diagrams with their relevant functions. These are the ICs we will see: IC 7474, 7475, 7476, 7490, 7493 and 74121. These ICs functionalities we will see in the coming classes. So let us start our discussion with the definition of sequential circuits. So the sequential circuit, a sequential circuit is specified by a time sequence of inputs, outputs and internal states. So before this topic we have discussed the combinational circuits. So the total digital circuits are divided into 2 categories, where one is the combinational circuit and another one is the sequential circuit. The combinational circuit, where the combinational circuit is the circuit, the output is depends upon completely present state of the input. And coming to the sequential circuit, the output of the sequential circuit is depends upon the present state of the input and also previous state of the output. That is nothing but some of the memory elements. The structure we will see here. So this is a sequential circuit example. The entire circuit we are calling as a sequential circuit. It has inputs and outputs. So coming to that, it's internally has a combinational logic circuit diagram. So this is a combinational logic circuit. The output of this combinational logic circuit we are storing in the memory. Based on the memory information, the details we again fed into this combinational circuit, and this feedback path. This feedback path is nothing but as previous output. The output of the combinational circuit is stored at the memory elements. The output of the combinational circuit is stored at the memory elements. This past information is going to the present combinational circuit. So this is a sequential circuit. So see here once again, it containing memory element. If it is storing the data, it is nothing but as it works like as a memory. And the outputs of the function, the outputs are a function of the current inputs and the state of the memory elements. So here, the output of this sequential circuit is present inputs and memory elements. Memory elements are nothing but as flip-flops. Memory elements are, for the memory elements, the examples are flip-flops, latches. Okay, right. The output is also depends upon the past inputs. The output is also depends upon the past inputs for some time. Right. So this is the generalized block diagram for the sequential circuit. Right. Next, coming to that, Types of sequential circuits. There are two types of sequential circuits. The first one, synchronous sequential circuit. Second one, asynchronous sequential circuit. So a sequential circuit is divided into two categories. The first one synchronous, second one asynchronous. Right. Now, synchronous sequential circuits. Synchronous sequential circuit. So the synchronous sequential circuits we can define with a small definition, that is, all the circuit elements are controlled by a single clock pulse. Okay, in this synchronous sequential circuits we have a group of flip-flops. All the flip-flops are controlled by a single clock signal. That is called synchronous circuits. So see here, the outputs of the sequential circuit depends upon not only the inputs but the state, but also the state or the current contents of some memory. That is the same definition which we have seen for the sequential circuit. That same sequential circuit definition here we have written. And the memory contents also change as the circuit runs. So order in which the things occur makes the difference. So whenever the inputs are changes, the output also changes. But coming to that order and the sequence is very, very important. That order and sequences are completely depends upon the sequential, synchronous concept. The clock signal allows the inputs to process generates outputs. Generally, in the sequential circuits, inputs are available readily, but the function is not going to work there. Okay, so see here, I am here, right? I am ready to teach. When I will start the teaching, when the students came to the college and sit in their places in the classroom, then I will start the discussion. Okay, so I have the knowledge. So I cannot deliver. Why? Because the audiences are very important. Okay. So if the faculty is ready, he is not ready to deliver the content. Why? Because the student has to present in the class. Then only he is ready to deliver the lecture. Where the students are the clock signals and faculty is the memory element like flip-flops or latches. That is, we have the circuit, but it is not ready to work. When it will start working, it based on the clock signal. So see here, this is very, very important. So the clock signal is very, very important. The clock signal allows inputs to process generates the output. So the inputs are readily available, but the inputs are not entered into the circuit. It waits for the signal of the clock. If the clock signal is came, then the inputs are processed into the outputs to generate the outputs. This is very, very important. So see here the example. So this is the circuit already we have seen for the sequential circuit. A small modification is there for this sequential circuit to form like as a synchronous sequential circuit. So see here. So this is the modification. The modification is the as clock pulse we are connecting to the memory elements, where all the memory elements are connected to a single clock pulse, So with that clock pulse only the complete memory elements are controlling. With this we can call this one as synchronous sequential circuit. So see here, in this memory elements, all the memory elements are connected to a single clock pulse. Then it is called synchronous clock. In the memory elements, each memory element is connected to a different types of clock signals. We have multiple clock signals here for the asynchronous sequential circuits. For the asynchronous sequential circuits, we have multiple clock signals. For the synchronous sequential circuits, we have only one clock signal, and that clock signal controls all the memory elements. Okay, so like that we can differentiate the synchronous and asynchronous sequential circuits. That we will see in later coming classes. We will see the synchronous and sequential circuit, synchronous and asynchronous sequential circuit differences or similarities we will see in the coming classes. Okay, now let us continue this discussion with latches. So the latch is the first sequential circuit element or memory element in the starting days. So the latch and flip-flop almost both operations are same, but these two are differentiated with very, very small differences that also we will see. So the first discussion is latch. A latch is a single bit storage device. A latch is a single bit storage device, and it is formed by using two basic gates. by using two basic gates that we will see now. So in this we will see that latch by using NOR gates and NAND gates. Okay, so we will start this discussion with using SR latch using NOR gates and SR latch with using NAND gates. Then we will continue the discussion D latch. Okay, these are the concepts now we will discuss. So this is a basic SR latch construction, right? And coming to here, where S and R, where S stands for set and R stands for reset. Okay, S stands for set and R stands for reset. That is very, very important. And see here, some of the content I have written, the important points. The SR latch can be considered as one of the most basic sequential logic circuit possible. Okay, in the sequential circuit, this is a very, very, very important and basic circuit. Okay, this simple circuit is basically a 1-bit memory bistable device. Okay, so this is the circuit we have brought from the different circuits elements configurations. We have multi-vibrators concept. There are 3 types of multi-vibrators: a stable multi-vibrator, monostable multi-vibrator, and bistable multi-vibrator. So this is the circuit, an application of bistable device. This is bistable devices. Bi means 2. Stable means 2 stable states are available in this device. These memory elements are examples from the bistable multi-vibrators. So bistable, 2 stable state. Stable means good state. Okay, stable state means good state. That is one of the fixed state and valid state. That type of 2 valid states are available. That is bistable. 2 valid states. That is S and R. S is a set operation, R is a reset operation. So what is meant by set and reset? Set means we have setted everything. That means we have arranged all the arrangement. That means here in the our binary side or our digital subject side, set means 1. Reset means 0. That is set means on, reset means off. Okay, set means on and reset means off. That is set is equal to 1 and R means reset is equal to 0. That is, if I switch on the device, that is the switch is in the on condition, that is 1, logic 1 it is representing. If I reset the device, that is I have switched off the device. Now the device state is logic 0. That is logic 0, logic 1 condition. So here we are saying. Okay, right. Now it has 2 inputs. S will set the device and R will reset the device. When you are setting the device, the output of the device is representing 1. When you are resetting the device, the output of the device is equal to 0. The device output is equal to 1. The device output is equal to 0. Right. For example, the AC is not working. So the AC repair person came to the department or to the house and he set the device. The setting means when he repaired the device, he will completely fix all the arrangements or all the repairs and he switched on the device. So when he switched on the device, automatically the device is going to set. So when you will set, the device is going to set when it is working properly. When it is working properly, you can say that the device is setted. Okay, the device is going to set. Okay, so when you will set reset, if the device is not in working condition, then you have to do the reset operation. So today and tomorrow, you can see all the electronic gadgets have a reset option. So one is the power on button and you have one more is the power reset button. The power on button is nothing but as you have, for example, your mobile, you are saying after you are buying the mobile, you will say, you will do that, you will save the contacts, okay, your father contact, your mother contact, all your relation contacts you have stored in that mobile, and whatever the apps you require, all the apps you are storing there, and finally after 2 days or after 3 days, you will say my mobile is completely set, right? My mobile is completely under set. Set means whatever the things you require, that all the requirements or all the conditions are satisfied with that device. That is nothing but as the mobile is set. Okay, the mobile is reset. Reset means after some days you will get some virus in your mobile. Then what you will do? You will reset your mobile. So when you are resetting the mobile, all the applications of the mobile you will lose. Okay, so your contacts you are going to lose, and your apps you are going to lose, and your photos you are going to lose. All the information you will lose. That is zero state. That is where the mobile is set means all the requirements are available. That is going to 1. So when you set the mobile is going to work perfectly. When you are mobile doing reset, that is you are using a reset operation, then the output of the mobile is 0. So mobile is there with us, but it is not going to work. Mobile is there with us, but it is not going to work. There is a set and reset operations. Okay, so set operation, reset operation. When you are giving some inputs, the output is going to set. So when Q is equal to 1, that is under reset condition. When Q is equal to 0, that is under reset condition. It is very simple. This is SR latch. This SR latch output, when the output is equal to Q, Q is equal to 1, then the complete device is in the set condition. When Q is equal to 0, the complete device is in the reset condition. So before that, before going to see this operation in deeply, first see here, you have 2 inputs, 2 outputs. So whatever how many number of the inputs you have, that is not countable. Here you have 2 outputs. These are the 2 standard outputs. The first one is original output. The second output is complemented output. If it is Q, this is Q bar. If it is Y, this is Y bar. If it is X, this is X bar. These are the 2 outputs here we have. That is, one is original output, second one is complemented output. For any type of flip-flops, we have 2 outputs. One is original output, second one is complemented output. So coming to that inputs, so in this SR flip-flop you have 2 inputs. In some flip-flops you have only 1 input. Either 2 inputs or 1 input. These are the configurations for the generalized flip-flops. Okay, right. So see here, the output of Q bar is always complement of Q. The output of Q bar is always complement of Q. So see here, remember one thing, if you have here 0, the output of here it is 1. If it is 1, the output here it is 0. So always these 2 outputs are reverse. That is very, very important condition. So that condition you have to maintain. If the condition is not maintained properly, then that is the state of forbidden state. That is invalid state. Forbidden state or undetermined state or invalid state. These 3 are same. Okay. So see here, if it is 0, this is must be 1. If it is 1, this is must be 0. These type of conditions are available, then you can say it is under reset or under reset. If these 2 are not there, if it is 0, if this is also 0, then it is a undetermined or invalid state. Both zeros and both ones are not acceptable here. If you got that type of outputs, then that is called invalid state. That is called invalid state. Right. Now see here, SR latch construction using NOR gates. SR latch construction using NOR gates. So in this class we will see this topic, SR latch using NOR gates. So before entering into the circuit, what is a NOR gate operation? NOR gate has 2 inputs, A and B, and output is Y. So NOR gate is the reverse of OR gate. What is the OR gate functionality? If any one of the input is equal to 1, output of the OR gate is equal to 1. That is, for 0, 0, the output is 0. For all the remaining combinations, output is equal to 1. This is the operation of OR gate. This OR gate operation we have to reverse. That reversed OR gate operation we are calling as NOR gate operation. That is, for 0, 0, 1. For the 0, 0 inputs, the output is 1. For all the remaining combinations, the output is 0. You have to remember. And you have to remember one more point. So this is the NOR gate. This is the NOR gate. See here, A value is equal to 0. Right? I fixed A value is equal to 0. Okay, now, right? Here, the 1 is not allowed here. The 1 is not allowed here. And the NOR gate output. What is the NOR gate output? What is the NOR gate output? Here it is 0. If it is 0, then what is the output? It is 1. If it is 0 and this is not 0, this is, if it is 1, what is the output? This is 0. Okay, see here, if 0, 0 is there, the output is 1. 0, 1 is there, output is 0. In this, I have fixed this value is equal to 0. That is, one of the input of the NOR gate is always 0. One of the NOR gate input is equal to always 0. So here, if it is the second input is 0, the output is 1. If it is the 1, the output is 0. So it is very simple thing. For the NOR gate, I have fixed the one of the input is 0. I don't know the second input. So one input is equal to 0 and another input is equal to some x. Now what is the output? What is the output? That is called x bar. So these are the inputs and this is about output. For the NOR gate, I know one of the input is equal to 0. I don't know the second input. Then what is the output? The second input, if it is x, the output is equal to x bar. If it is y, the output is equal to y bar. If it is z, the output is equal to z bar. Okay, so this is the condition. Now take, if here I have fixed the one of the input is equal to 0. Now I am erasing this one. Now I am taking one more combination. So now here one of the input is equal to 1. That is, I have taken this combination. Now I have taken this combination. Now coming to here, see second input. If the second input is equal to 0, output is 0. If second input is equal to 1, output is equal to 0. Right? So here, see, it is very important operation. If one of the input is equal to 1, if one of the input is equal to 1, if the input is equal to 0, output 0. If the input is equal to 1, output is equal to 0. That is, so see here, whatever the input here we have, whatever the input, second input here we have, the output is 0. It is very simple. So see here, I have fixed one input is equal to 1. Okay, but I don't know the second input. I don't know the second input. For example, consider this one as x. So the x may be 0, the x may be 1. I don't bother about that one. The output is equal to 0. For whatever it may be the condition, the output is equal to 0. So see here, once again I am saying here, one of the NOR gate input is equal to 1. Then I don't know the second input. So the second input may be 0 or 1. But I don't bother. I don't want to know that one. I don't want to know that one. The output I am saying that 0. So you can say the NOR gate output like this. If one of the input of the NOR gate is equal to 1, irrespective of another input, you can say the output is 0. Okay, na? Right? So if now one of the NOR gate input is equal to 1, automatically the output is 0. Don't see the second input. Don't worry about the second input. This is very important basic. Right? So I am erasing everything. So remember one thing. For the NOR gate, if input is equal to 1, output 0. That is a condition you have to remember. Okay? Right. Now, coming to that SR basic operation. So this is the NOR gate connection. This is the NOR gate connection for the SR latch. So I have taken one NOR gate here and I have taken one more NOR gate here. So see here, I will draw here. So this is the first NOR gate I have taken here. So and the second NOR gate I have taken here. For explaining the SR logic operation, I have taken two NOR gates. Why? Because each latch or flip-flop, it has two outputs. So one is Q and second one is Q bar. For getting two outputs, I have taken two NOR gates. And one input of first NOR gate is equal to S, and the second input of another input of another NAND gate is equal to R. I have taken S and R. So see here. From this diagram I have taken R and S. Alright, R and S. I have taken one input is equal to R and another input is equal to S. I have taken two inputs. Okay, right. So another input of this NOR gate I have taken from the output of this first second NOR gate. So this first one, second one. Okay, the second input of first NOR gate I have taken from the second NOR gate output, and second NOR gate, one of the input I have taken from the first NOR gate output. Right, it's very simple concept. I have taken two NOR gates. For the NOR gates, I have two outputs. One is Q and the one is Q bar. And this NOR gate has two inputs. One input I have represented R, and another input I have connected to this another NAND gate output. Here also, for one of the NOR gate I have connected input is equal to S, and another NOR gate input I have connected to the another NAND NOR gate output. So this is the basic connection. This is the basic connection. Now, here you have to write down the truth table. Here you have S, R, two inputs here you have, and here Q, Q bar. Q bar combinations are available. Right. In this 0, 0, 0, 1, 1, 0, 1, 1. Okay, four combinations are available. Okay, for these four combinations, what are the outputs? What are the outputs? So see here, first take 0, 1 combination. Take 0, 1 combination. S is equal to 0, R is equal to 1. S is equal to 0 and R is equal to 1. Okay, right. So what is a NOR gate condition? If any one of the input is equal to 1, automatically the output is R. The output is equal to 0, right? Output is equal to 0. So here R is equal to 1. Automatically the Q output is goes to 0. The Q output is goes to 0. This 0 is connected to this NOR gate. This 0 is connected to this NOR gate. Here already one of the NOR gate input is equal to 0 and another input of the NOR gate is equal to 0. This is 0. This 0 I have taken. 0, 0. What is the output? For 0, 0 combination, NOR gate output is equal to 1. That one I have written here. That one I have written here. Okay, right. And this one you have to connect here. This one is connected to here again. So what is the 1, 1 combination output for the NOR gate? Here 1, 1. What is 1, 1? 1, 1 is equal to 0. So the output is equal to 0. Already we have kept the value is equal to 0. Right? So this is the operation. So for the 0, 1 combination, Q is equal to 0 and Q bar is equal to 1. Q is equal to 0 and Q bar is equal to 1. So see here. S value, S means set. Set value, that set to switch. So here I have two switches. Set to switch, reset switch. I am not pressed the set button. I have pressed the reset button. So when I have pressed the reset button, the system is going to the off state. Q is the original output. You have to bother about the original output. Q is the off state. So when you resetted your mobile, reset is equal to 1. So that means you resetted your mobile. When you reset your mobile, then automatically the output is 0. Right? Your contacts you will lose, your every information in your mobile you will lose. That is equal to 0. Right? Next, coming to that 1, 0 combination. 1 means you are giving the set input is equal to 1. You are switching on the set button. Then automatically that output you have to go with 1. That also we will see. So see here, R is equal to 0 and S is equal to 1. So this is the combination now we are concentrating. R is equal to 1, R is equal to 0 and S is equal to 1. So S is equal to 1, R is equal to 0, just forget. So one of the input of the NOR gate is equal to 1. Automatically that NOR gate output is equal to 0. Okay, this 0 is connected to here. So here already 0 and this NOR gate input is also 0, but 0, 0 combination the output is equal to 1. So see here 0, 0 combination the output of the NOR gate is equal to 1. So now the outputs you got, Q is equal to 1, Q bar is equal to 0. So Q is equal to 1 and Q bar is equal to 0. Okay, so when you switch on the set button, your output is also going to switch on condition. When you are switched on when your set button is going to switch on, the output also going to switch on. Okay, so this is S is equal to 1, R is equal to 0. S is equal to 1, R is equal to 0. Right. Now, so 0, 1 combination and 1, 0 combinations are completed. Now we will see remaining two combinations, that is 0, 0, 1, 1. 0, 0, 1, 1 combinations. Now we will see. Right. So 0 0 combination. I have given the value R is equal to 0. Now I have given the value of S is equal to 0. R is equal to 0 and S is equal to 0. Right. So these two combinations are 0 0. Here now we will see the combination R is equal to 0, S is equal to 0. See here, if it is 0, the output is depends upon the another input that we have seen for the NOR gate. Here it is also 0. Now the another input has to decide the output. So then nothing but this is nothing but as here you can say the S input and R input both are 0 0. Now you have to say that what is the output. If it is 1, you can say the output is 0. If it is 0, the output is complement of the second input, the complement of the second input. So we cannot decide the output. Okay, so R is equal to 0, S is equal to 0. For example, now I am giving S is equal to 0, R is equal to 0. But previously the outputs of these two may be 0 1 or 1 0. Maybe just assume that the Q is equal to 0 and Q bar is equal to 1. Previously the output Q is equal to 0 and Q bar is equal to 1. Now I have given S value and R value both are 0 0. Now we'll check that what is the output. So see here, if Q bar is equal to 1, here this is 1. Here Q is equal to 0, now this value is equal to 0. Okay, so see here, for this NOR gate, we have the inputs 0 1. If 0 1 is there for the NOR gate, what is the output? 0. Here 0 1 is there, the output is 0. Previously output 0, present also the output is 0. Previously I said that the output 0, present output also 0. Next, this 0 is connected to here. 0 0. For this second NOR gate, both inputs are zeros. Now, so see here, both inputs are zeros. What is the output? 1. So here the output is equal to 1. Already previously the output is 1. Present output also 1. So previously I have taken 1 and present output is also 1. Okay. So the previous outputs are 0 1. Now the present outputs are also 0 1. Okay. Now you will take like this. Now you take like this. Now take here, I said that R is equal to 0, S is equal to 0. Now here Q is equal to 1 and Q bar is equal to 0. Previously we have taken 0 1 combination. Now I have kept here 1 0 combination. Okay, see here, this 1 is connected to here. Now here the input is equal to 1 and here this 0 is connected to here. So now the inputs are 0 0. Here now the inputs are 1 0. Okay, if any one of the input is equal to 1, automatically the output is equal to 0. Right, now the output is equal to 0. Previously the output is equal to 0. Present, now this is also 0. This 0 is connected to here. Those two inputs are 0 0. When these two inputs are 0 0, the output is equal to 1. So the present output 1. Previously the output is 1. Here the present output 0, previously the output is 0. So previously 1 0 outputs are available, presently also 1 0 outputs are we got. So there is no change. When you are giving the S is equal to 0, R is equal to 0, there is no change for the outputs. If previous outputs are 1 0, present outputs also 1 0. If previous outputs are 0 1, now the present outputs are also 0 1. So you can't say this is 0, this is 1. So you can say the previous output we are following. The previous output here we are following. For example, this is the Q1 output, this is the Q1 bar. Then the output Q0 bar is are available here. Okay, where 0 is nothing but as 0th time slot and 1 is nothing but as a first time slot. If the present outputs, that is the present time slots, and 0 is the previous time slot. Okay, so the previous outputs are followed to the present outputs. So this is the combination. Next, coming to here, the next last logic, that is equal to S is equal to 1 and R is equal to 1. Right? S is equal to 1 and R is equal to 1. For this combination, see carefully. S is equal to 1, R is equal to 1. We know that if any one of the input is equal to 1 for the NOR gate, output automatically 0. And see here, for this NOR gate also, one of the input is equal to 1, the output is equal to 0. I said that previously, the Q bar must be reverse. if both are seems to be same value, that is the invalid state. That is the invalid condition. Okay, that is the invalid condition. Our mobile may be in the reset condition or maybe set condition. Both conditions are available at the same time. No, it is not possible. So here this 1-1 combination is invalid state. At this time there is no outputs. If you are giving the 1-1, the output is the invalid state. You don't take that output combination. You don't take the output input combination. There is no output. That is the invalid state. So see once again. So see once again. So this is the S input. This is the R input. The SR values, and this is Q. This is Q bar. Okay, set condition, reset condition. Coming to the truth table, here you have the maximum possible combinations 0, 0, 0, 1, 1, 0, 1, 1, and QT plus 1. That is the time period. You have to define the time period. So the time period 0th second, 1st second, 2nd second, 3rd second, 4th second. If you have the line time slots like that. So see here, T is equal to, for example, 5th second. So QT plus 1 is the 6th second. So the present output is the 6th second, and the QT is equal to 5th second. So previous output at the 5th second, whatever the output is available at the 5th second, the same outputs are available at the 6th second. That is for the 0-0 combination. So see here, 0-0 combination, and this QT plus 1 and QT plus 1 are the present state outputs, and QT bar are the previous state outputs. So these are the present state outputs, and these are the previous state of the outputs. So the previous output follows as is for the 0-0 combination. Next, for the 0-1 combination, so when S is equal to 0, R is equal to 1, the output is equal to 0. This is also just now we have seen. And when S is equal to 1, R is equal to 0, output is equal to 1. That is, set is equal to 1. When you are going to set your system, the output is going to set. That is equal to 1. When you have 1-1, both outputs are generally seems to be 0-0, but this is not valid state. This is called forbidden state or invalid state. This state is called forbidden state or undetermined state or invalid state. In each one of all the textbooks are defining all the different names. Some of the textbooks they are writing invalid state, some of the textbooks they are writing forbidden state or in undetermined state. So whatever may be, all the states are here common. Okay, so this is about SR latch by using NAND gates. So NOR gates. SR latch by using NOR gates. Okay, right. Thank you.